Hello, everybody. Uh, Thank you to give us a chance to be in this scientific event, and thanks for all organizer of this scientific event or scientific conference. I would like to introduce myself. My name is Mustafa Adil Faiz. I'm from Altınbaş University, Istanbul, Turkey. I have PhD in data science and artificial intelligence. Today, I will show or present my work with title Hybrid Ensemble Models for CHD classification. This presentation explores a hybrid stacked and tuning ensemble models, enhancing the classification of coronary heart disease (CHD) using a multi-dataset approach. We will cover model definitions, data source, performance evaluations, and future directions, showcasing the potential of advanced machine learning techniques in clinical application. Model overview. Our objectives or contributions develop a coronary heart disease or CHD classification framework with high accuracy. Approximately, we achieve 99.7 as a best accuracy from our models, designed model. Integrate stacked and hybrid ensemble learning techniques, apply on 6 real-world clinical datasets, ensure clinical applicabilities through robustness and evaluation. What is stacked model? Stacked models combine a multiple machine learning algorithms to aggregate their strength by training these algorithms on a various dataset subsets. Stacked models improve prediction accuracy by aggregating diverse insight into a single covariance output. So the basic work for or basic structure of stacked models based on some algorithms, model 1, model 2, model 3, or some other models combined together to create, or based on this learner model, we can create a new learner model to enhance the performance of our prediction model. Here, tuning ensemble model enhance base model through optimized hyperparameters and configurations of these algorithms. This approach ensures that individual models are not only strong independently, but also function optimally when combined, leading to a robust performance and classification task. Here we have two figures explains or describe the work of stack model and tuning model. In a stack model, we see here the base models, random forest XGBoost and linear regressions as an example of base models. From these learner models, we can create a meta-learner models to get the final predictions. With tuning model, the input clinical data go for a tuning model directly, and by tuning the parameters or some configuration of these parameters to get the best parameters work for these type of datasets to get the final predictions. The base model 1 in figure 2, base model 2, base model 3 as example from the input data to create a meta learner based on these models to get the final prediction. Hybrid approach offers significant advantage in model performance, accuracy, and resilience to overfitting. By integrating diverse methodologies, they can better capture complex patterns in data, leading to more reliable predictions and enhanced clinical relevance. The structure of the hybrid models that here, the original data goes over model 1 residual data to model 2 residual forecast, and the initial models or the first model also have the initial forecast. Based on these two models, we can get the final prediction task. So the output of the first model would be the input to the second model to get the final decision. Data source. Utilizing multiple datasets for training enhance model generalizations and reduce bias. The approach draw on a wide data samples representing different populations, making on the model more applicable for working with real-world scenarios and improving its predictive capabilities. The datasets that we got from a scientific websites like Kaggle or UCI repository, these websites support you with any type of dataset that you need to test your models or designed models. The name of our dataset that you used, Cleveland, Hungarian, and Switzerland, Long Beach, and hard.csv with two class and multiple class, five classes predicted. All dataset contains 13 clinical features such as age, blood pressures, cholesterol, and other constraints. Class type binary and multi-class here for prediction. The data collection methods range from clinical trees to electronic health records. The integration of diverse data types, including demographic, clinical, and lifestyle information, enriches the dataset, providing a comprehensive view of the effective model training. The overview of our data that you used here, the Clevelands with 303 instance and 13 features, or the dataset have the 13 features and close to each others with instance 304 with hearts.csv, 200 with Long Beach, and 294 Hungarian, and 123 with Switzerland. Data preprocessing techniques. Before we dealing with our data to test our performance models, we should make some preprocessing of these data using some preprocessing techniques like that to increase the effective of our models. The data preprocessing involve cleaning, normalizations, and transforming data to enhance model performance. Techniques such as handling missing value, feature scaling, and encoding categorical variables ensure that the input data is suitable for analysis with our models that designed for these tasks or classification tasks. Thereby improving the accuracy and reliability of the model's predictions. The proposing that we did in our case, dropped attribute with more than 20 percentage missing values because it will be not benefit for work with our models. Impute numerical data using main values, z-score normalization applied, categorical variables encoded using one-hot encoding technique, and feature selection by RFE, random forest elimination techniques, and correlation analysis. Our model performance. The key evaluation metric for model performance include accuracy. How can we test the performance of our models using some constraints, including accuracy, or curve, precision, recall, and F-score that we used here. This metric is the model ability to correctly classify the instance of coronary heart disease, providing a comprehensive overview of their effectiveness and identifying areas for improvement. The table here show the classifier performance across the datasets that we used because we used multiple datasets to make our model give a high performance for work with multiple datasets at the same time. With random forest, XGBoost, AdaBoost, some algorithms, logistic regressions, support vector machine, k-nearest networks, naive that we use here as tuning model and stacked models and hybrid models. We got 94 percentage accuracy in Cleveland with random forest, 99 Hungarian, 2 class, and 99 with 5 class. Switzerland 95 as a best accuracy and 90 with XGBoost. Long Beach 91 random forest and 85 with XGBoost. Heart.csv 85 and 86 and 87 as the best accuracy with logistic regression. The comparative analysis with traditional models highlights the significant performance enhancement through a hybrid approach. By examining metrics from convolutional models, various hybrid ensemble models, we can illustrate improvements in the classification accuracy, stance, and generalizability across a diverse datasets. The model used based models that we used, random forest, XGBoost, AdaBoost posting models, support vector machine, SVM, k-nearest network, KNN, logistic regression, naive with the very famous algorithms for work in many tasks for classification tasks with some models. Hybrid assembly, we used a majority voting. Stacked Ensemble, random forest, XGBoost, linear regression as based, and gradient boosting as a meta. In this figure, we see the yellow with before toning and other with after toning. So we see here before toning the same model, we got some accuracy, and after the toning, this after toning the same models like AdaBoost, XGBoost, Random Forest, we got the performance here. We see the difference or the big difference between them and random forest close to each other, but the best one will be with tuning models, and the tuning XGBoost is better than a normal GBoost for work and classification, and AdaBoost tuning AdaBoost will be for more suitable for work or high performance and give high accuracy for work than AdaBoost and normal model. Case study and results. Real-world case studies demonstrate the practical application of hybrid models in CHD classification. By analyzing results from well-documented studies, we can showcase the superior performance of these models, including their impact or on diagnostic accuracy and patient outcomes. The result of our study includes stacked ensemble. We achieved 99.7, as I said in the previous slide, accuracy on Hungarian two-class dataset, or curve close to 1, including or indicating that excellent separation. Hyperparameter tuning improved all models. Voting ensemble also show the strong robustness. In these figures, we see the random forest tuning. We got 0.99 as a best OG, and XGBoost also 99.6, stacked ensemble 99, close to each other. We see the effective on the performance of our models using tuning and stacked model. In figure 5 here, we compare the accuracy of OCROC scores for the advanced model after applying hyperparameter tuning and integrating hybrid ensemble strategies. The stacked ensemble model outperformed all other models with an accuracy of 99.7 and the raw curve close to 0.99.9. The use of hyperparameter optimization significantly enhanced classifier performance, as I said, by fine-tuning a critical parameter controlling model complexity and generalization. So the tuning models, when we working with some edition or edit some the constraint parameters of the algorithms before working with datasets will be very beneficial for work with these datasets and give high performance results. In these figures, we mentioned the random forest tuning model close to 100, XGBoost also close to 100 tuning model. Or of this, we not forget the hybrid voting ensemble also close to 190.99, and stacked ensemble model also close to 100 here. In our future directions, our research should focus on expanding the datasets that used, exploring a novel hybrid techniques, and integrating more advanced machine learning algorithms. This approach will enhance the model predictive power and potentially open new avenues for CHD research and treatment. Our future work includes incorporate with EHR and real-time monitoring, develop decision support tools for hospital deployment, adopt explainable AI or shape and line. Scalability is critical for the practical application of hybrid models in clinical settings. Future developments should prioritize optimizing model architectures and a training process, ensuring they can efficiently handle large datasets while maintaining high performance. Integration in clinical practice. Integrating these models into clinical practice requires a collaboration between data scientists and healthcare professionals. It's very important here. Developing user-friendly interface and decision support system will aid clinicians and uh, interpreting model outputs, ultimately enhancing patients' care and decision making. In conclusion, hybrid stacked and tone ensemble models provide a significant advancement in coronary heart disease classification through effective data handling, robust model evaluation, and strategic future research directions. This approach promises to enhance diagnostic accuracy and clinical applicability. Finally, we conclude our work as some points hybrid and stacked models outperform single machine learning model a proposed system over scalable and accurate CHG prediction, and simple strategies enhance generalizations and clinical trust. Thank you for your attention. And if you do have any questions, I am the corresponding author of this work. My mail is mustafa302 at gmail.com, and this is my research gate. And thank you for your attention.